Hello and welcome to the GCSE Chemistry tutorial for topic C6, the rate and extent of chemical change. This is part 1, rates of reactions. We'll be looking at rates of reactions and measuring the rate of reaction. First of all, the rate of reaction is how long it takes for reactants to turn into products. A slow rate of reaction might be something like a piece of iron rusting, a fast reaction like fireworks. Rates of reactions depend on something called collision theory. The rate of a chemical reaction depends on how frequent there are collisions, so how often particles collide, and the energy transferred during collisions, so how much energy they have when they're colliding. The minimum amount of energy that reactants need to break bonds and get started in a reaction is called the activation energy. And there's 4 factors that can increase the rate of reaction. Temperature, so increasing the temperature means that you're increasing the energy of the particles. Concentration or pressure if it's a gas, increasing the concentration means you're increasing the frequency of particles colliding. Surface area, that increases the area where reactants can collide with. And finally, the addition of a catalyst. We're going to talk through each one. First of all, a rate of reaction can be plotted on a graph, and they all have this shape here. The steeper the curve, the faster the rate of reaction. The faster the reaction, the quicker the reactants will turn into products. Starting with temperature. When particles are heated, they gain more energy. When they've got more energy, they'll move faster. That means they will collide more often and cause more successful collisions. More collisions with more energy makes a reaction faster. Concentration. If you increase the concentration or the pressure of the reactant, there's going to be more particles in the same volume. That means there's going to be more collisions and more successful collisions. A higher frequency of collisions makes a reaction faster. Surface area. This only comes into account if one of the reactants is a solid. So if one of the reactants is a solid, you can increase the surface area. If you do that, that means there's more area for the collisions to occur on. There's not more of the actual reactant, there's just more surfaces. This increases the number of successful collisions. For example, using powdered calcium carbonate reacts a lot faster than using large pieces of it. Finally, a catalyst. Catalysts are added to reactions to speed up the rate of reaction, and they don't get used up in the reaction themselves. What they actually do is they lower that activation energy needed to start the reaction. So they don't get affected in collisions or frequency of collisions, they just lower the energy that the reaction needs to get started in the first place. An example of a catalyst is enzymes, which are biological catalysts. So how do you measure reaction rates? Well, you can either measure the amount of product made or the amount of reactant used up. There's different ways you can do that. You could use a gas syringe to measure the amount of gas, or use scales to see how much the mass changes, or perhaps look at colour change. There's 2 examples that you need to know. First of all, collecting a gas. This practical is between magnesium and hydrochloric acid. You'd add a known volume and concentration of hydrochloric acid to a conical flask. You then add a piece of magnesium ribbon, which you've measured out and know the size of. You quickly attach the bung and gas syringe, make sure the gas syringe is pushed all the way in, and then start the stopwatch. And then you record how much hydrogen gas is formed every 10 seconds for 2 minutes. So you'll get a lot of results. And then you can repeat and then change a variable. So you might change the concentration of the acid and see if that affects how much gas is made. Or you might change the surface area of the magnesium and turn it into a powder. If you're changing one thing, you keep everything else the same, and then you'll plot your results on a graph. Another practical is a reaction between sodium thiosulfate and hydrochloric acid. When they react, they make a yellowy precipitate. You'd add sodium thiosulfate to a conical flask and place it on a piece of paper with a cross on it. You then pour in a set volume of acid, start the stopwatch, and you time how long it takes for when you can no longer see the cross. This is often called the disappearing cross experiment. You then repeat this and you can change different things, for example, the temperature. If you pause the tutorial now and try and answer this 6-mark question in 10 minutes, describe the factors that can affect the rate of a chemical reaction. Well, for a reaction to occur, particles have to collide with enough energy. And there's 4 factors that can affect the rate of that reaction. Temperature, so when particles are heated, they gain more energy, they move faster, which means they collide more often and cause more successful collisions. Concentration, when you increase the concentration, there's more particles. That means it increases the frequency of collisions. More collisions means the reaction will be faster. Surface area. Increasing the surface area of one of the reactants, if they're a solid, means there's more space for collisions to occur, so the reaction is faster. And finally, adding a catalyst lowers the activation energy, which means the reaction will occur faster. You might also want to draw some particle diagrams to explain each of those factors as well. In summary, we've looked at rates of reaction and measuring rates of reaction, looking at 2 practicals.